Hello once again, welcome back. In this chapter, we're going to look at how variables are passed into methods in Java. We'll first talk about what it means when we say that objects are passed either by value or by reference, and we'll learn which of these options applies in Java. As we'll see, it can be confusing, so we are going to spend some time understanding why it works the way it does. This is important as it will help you understand exactly when the apparent values in variables can and can't be changed by the methods that these variables are passed into. And then we'll look at the final keyword, which is the closest thing we have to constants in Java. And at the end of the chapter, there's going to be an exercise for you to do. But for now, let's make a start by looking at some simple Java code. When we looked at how the stack and heap work, we learned that objects are stored on the heap with local variables on the stack containing references to the object on the heap. Let's look at what happens when you call a method in Java and you pass parameters into that method. We'll test this with some simple code in Eclipse. I've created a new project here called memory and a main class that's runnable. So in this class, what I'd like to do is start off with a local variable, which will make that an int, and let's call it local value, and we'll give it an initial value of 5. Now I want to call a method passing that local value into the method, so we'll create a second method here. That will need to be public and static as we're in the main class. And we'll make this a void method. It's not going to return a value. We'll call it calculate. And this method is going to accept one parameter of type int. And here we'll call it calc value. And within this method, what we'll do is multiply calc value by 100. So we'll do calc value equals calc value times 100. Okay, well now that we've got that method, we can call calculate, passing in our local value. And then let's print out to the console the value of local value after calling calculate. Before we run this code, let's guess what the output will be. Our starting point is the rule that when you pass a value into a method, you are always passing a copy of that value. So just before the calculate method is called, there's going to be a local variable on the stack called local value, and it'll have a value of 5. When we call the calculate method, the variable calc value will be created on the stack. This will be assigned the value of 5, but we now know that this variable is a copy of the local value variable. So if we change the value of calc value, this won't affect the value of local value. That should remain at 5. So as the line runs that multiplies calc value by 100, local value stays at 5. The calc value variable is going to be popped off the stack when we return from the calculate method. And so when we print out the value of local value, we expect we should get the number 5 output. Let's run that in Eclipse to check that is what happens. Well, in our console there, we have indeed got the number 5. Note that the variable in the method is always a copy of the value passed into it. It doesn't matter what the name of the variable is. I could have called this variable here local value. For example, obviously I'd need to rename these two to local value also, but the point here is that this would still be a copy of the local value variable that's passed into that method, and altering this one here will not affect the one here. Because it is a copy, it's not the same variable. So passing variables into methods in Java is always done by making a copy of the variable. This is known as passing the variables by value. Some other languages allow you to change this and pass the variables by reference. For example, Visual Basic has a by ref keyword. If Java did allow this, then you'd be able to write code that looks something like this. Here, I've added the byref keyword into the method call. Now, you can't do this in Java, but if we imagine that this was allowed, well, what would the output then be? This time, we would set the local variable to 5, and when we call the calculate method, we'd be passing in a reference to this local value. So we won't be taking a copy called calc value, we'll be saying calc value and local value are the same variable which currently have a value of 5. When we run the line that does the multiplication, that would make this have a value of 500, so that when we return and print out the value of a local variable, we'd get 500 printed out. But this is something you cannot do in Java. There is no byref keyword, and variables can only be passed as values. As an aside, if you have used a language that supports passing variables by reference, then you'll know that their main use is to create methods that return multiple values. In Java, we do have a standard way to do this, which is to wrap the multiple outputs into a class and return one instance of that class. So although we don't have the byref keyword in Java, it's not generally something that we miss. Passing variables into methods by value can sometimes, however, be confusing. And that's because when you call a method and you pass in an object as the parameter, rather than a primitive data type like we see here, then the variable that contains the reference to the object is what is passed. To state this more fully, when an object is passed into a method as a parameter, a copy of the variable on the stack containing the reference to the object is passed, and it's this variable on the stack that is passed by value. It means that a copy of the pointer to the object is created. The object itself is not copied, and in fact it's not the object that's passed into a method, but rather a pointer to the object. For example, if we pass a copy of a list into a method, then the parameter value will be a copy of the myList variable, which is a pointer to the object on the heap. So I hope that's clear. Many programmers misinterpret this as objects are passed by reference, but they're not, and let's look at an example of why this is significant. Here's some code which creates a customer and then calls a method which changes the customer's name and prints out the customer's name at the end. Assume that the customer class has been well written and it has get and set methods as you'd expect. What would the output to this be? I suggest you pause the video and work through this example using the stack and heap pictures that I've been showing you to work out what would happen. When you've had to think about it, press resume on the video and I'll talk it through. So let's talk through this example. First of all, we have a line that creates the new customer object. The constructor of the customer takes a string, so the first thing that will happen is a string will be created on the heap. Then the customer will be created with a property that references the string object, and a variable will be created on the stack pointing to this customer object. When we call rename customer, because we pass the value of the customer by value, a new variable will be created on the stack called cust, which will be given a copy of the pointer to the customer on the heap. Now we change the name of the customer. I hope you remember that strings are immutable in Java, that is, you can't change the value of a string. If you do this, you actually create a new string object. So what happens when this line runs is that a new string object is created on the heap, and Java changes the pointer from the name in the customer object to this new string. The original string object is no longer referenced from anywhere, and so it can be garbage collected at some point in the future. Finally, we exit the rename customer method and go to the print line. And now our C variable references the amended object customer, which has a name pointing to the new string Diane. So the output should be the name Diane. I hope you were able to predict this outcome. If you were, then well done, as this means that you now do understand the mechanism of how variables are passed between methods. Now that we understand this, let's have a look at the final keyword. If you haven't used final before, then this keyword is used to say that a variable can only be assigned once. Once it has been assigned, it can never be altered. It's the closest thing we have to a constant in Java. It isn't quite the same as a traditional constant that you might find in other programming languages because we can change the value from uninitialized to having a value. So the code I'm showing you on screen here would work fine. But the point of the final keyword is that if we try and change its value, in this example assigning it to a new customer, well, this second line would give us a compile error. The actual error message we'd get in Eclipse is final local variable C cannot be assigned. It must be blank and not using a compound assignment. The second part of that compile error message is rather horrible, but at least we understand the first part. We can't assign the final variable C, and that's because it already has been assigned. Now, when I described the final keyword just now, I said that we get an error if we try and change its value. Actually, although this is what many developers say, it's not quite right. And that's an important aspect of the final keyword that we can now understand because of what we know about how variables are stored on the heap and the stack. When we say that the final keyword means that a variable can only be assigned once, what we mean is that when the variable in the stack is assigned to an object in the heap, then we can't change which object in the heap this variable points to. The final keyword stops us doing that. But we can change the object in the heap if we wish. For example, we could change the customer's name. I could write a line of code to set the name of the customer from John to Susan. This would change the object in the heap that the name field of our customer points to, and this is perfectly valid code. There will be no compile error here, and the object does indeed change its value. In fact, it's not possible in Java to fix the state of an object and make it completely unchangeable. In other languages where this is possible, the feature is known as Const correctness. Const correctness is a powerful concept because it allows us to write much safer code, but I'm afraid this is just something that is not available in Java. Right from Java 1, the keyword const, which in the C programming language is used to achieve const correctness, was made a reserved word. If in Eclipse I try and declare a variable using the keyword const, and we'll just do a string and set it equal to hello as an example, we can see that the const keyword has been put into, I think the color's called magenta, highlighting that this is a reserved keyword. But as you can see, this code won't compile, and rather unhelpfully, the message we get is a syntax error on the token const. There was an open issue for a few years for the Java committee to implement const, but this unfortunately was closed many years ago, and so it looks like now we'll never have the const keyword implemented. It is a shame that Java doesn't provide const correctness, and what this means is that you have to be very careful in any method that accepts an object as a parameter. If you call a method on that object, you might be mutating its state, and these changes could be felt outside the scope of that method. To explain what I mean, let's have a look at this example. Here I've got some basic code that's going to create a customer called John and then print out the customer's name twice. And the question is this code safe? Well, we're creating a final customer whose name is John, and we're not calling any methods which should change the state of this customer, so it looks like this should be fine. But actually, we don't know this for certain unless we know the implementation of the getName method. Let's suppose the person who wrote getName created code that looked like this. Well, now this application would provide some rather unpleasant output. On the first call to getName, we'd get the customer's name John printed out, but on the second call, we'd get XXX. Now, this may be an unrealistic example because, of course, you wouldn't expect a get method to change a value, but that's only a convention and there is nothing in Java to stop you writing code like this. You may well find from time to time that an object you're working with suddenly has incorrect values and you can't work out why, and this could often be the explanation. There is a method call which looks like it's safe, it looks like it isn't going to change an object's state, but in fact it has done. It has something in there which changes the state of the object. Because the object is declared as final, this is even more difficult to spot if you wrongly assume that final objects can't be changed. We need to remember that it's only the reference of which object the variable points to that can't be changed. Many projects impose a coding style rule that all parameters passed into a method are declared as final. There are lots of code analysis tools like PMD, for example, which enforce this rule as a default setting. So you may well work on projects that require the use of the final keyword yourself. It is a perfectly good rule. It aims to ensure that you don't accidentally overwrite any variables. But because of the lack of const correctness in Java, and because using final, as we've seen, doesn't prevent this potential side effect, the ability to mutate an object's state, at Virtual Bird Programmers we don't choose to follow this rule, and you won't see it on any of our courses. To finish this section, I'd like you to have a go at an exercise which will allow you to test if you have understood how variables are stored on the stack and the heap correctly, and this will include passing variables by value into a method. In the starting workspace for this chapter, you'll find a Java project called Memory Test. I'd like you to load up this project into Eclipse, but do not run the project. Instead, read through the code, and the question you need to answer is predict what the output of this code will be. Now, I think this is a little bit of a challenge. What happens in the code is really quite complex to think about, even though the code itself is reasonably simple. So I suggest you draw a stack and heap diagram like I've been doing and use this to work through the code. So pause the video now and give this a go. You can check if you got it right by running the program, but on this video there will be a full walkthrough. If you did get it right and you're comfortable that you understand how this works, you don't need to watch the rest of this video, you can go straight on to the next chapter. But pause the video now and give this exercise a go. So I'm now going to walk through this exercise. Now, obviously I've got a limited size screen and it can be a little bit difficult to get everything that's relevant to show you on screen at the same time, and things might look a little bit messy, but bear with me and hopefully this will make sense. We start in the main class and in the main method of the main class. Now there will be a variable called args, which is going to be on the stack, but I'm not going to include this in my diagram as we aren't using that variable in any of the code. So the first line in the main method creates a new instance of the main class and it assigns it to a variable called main. So there'll be an object on the heap of type main, and there'll be a reference to that object on the stack with the name of main with a lowercase m. Our code then calls the start method in the instance of our main class. So the first thing that happens in the start method is we get a variable called last, which has a value of z. The last variable is a local variable, so this will be on the stack, and it will point to an object on the heap with the value of z. I should have perhaps said that as we're in the start method, the main variable is now out of scope. Next, we'll be creating an instance of the container class. Once again, there'll be an object on the heap of type container and a variable on the stack pointing to it. Let's look then at the container class. Well, when it's instantiated, there's a variable created called initial with a value of a. So the object will be created on the heap with a value of a referenced from the container. The next line in the start method calls the setInitial method of the container class, passing in another new object. This time it's a string with a value of c. So the string with the value of c will be created on the heap, And in the setInitial method, the reference from the container class will be changed from the A string object to the C string object. At this point, there's nothing referencing the A string object, so at some point it will be garbage collected. To keep this diagram as simple as I possibly can, I'm going to remove that A object now. The next line of code calls the another method, so let's have a look at that one. Note that it's passing into the method the variables container and last. So here's the another method at the top of the screen, and this method has two variables in its declaration called initial holder and new initial. So the initial holder variable will be a copy of the container variable, and the new initial variable will be a copy of the last variable. Remember that these variables are being passed into the method by value. So a copy of the values of last and container are being made into the new variables initial holder and new initial. And now that we're in a new method, of course, last and container are out of scope. As before, I'm using different coloured arrows just to keep the diagram simple. There's no meaning to the colours that I'm using. Now the next line of code calls the toLowerCase method. This was a little bit of a trick. Calling toLowerCase will create a new string object on the heap with its lowercase value, but this method doesn't change the existing string. If we'd wanted our new initial to become a lowercase z, we'd have had to write a line of code that is new initial equals new initial dot to lowercase. Because we didn't do that, this object that gets created, the lowercase version of our new initial, will never be referenced by anything, and so in fact it's immediately available for garbage collection. Again, to keep the diagram simple, because this object can never be used, I'm going to remove it from the diagram straight away. Our next line of code calls the setInitial method on the initial holder object, passing in a new string with a value of b. So an object will be created on the heap with a value of b, and when we call the setInitial method, the reference from the initial within the container will be changed to this new object. Now we've got our string of C, which is no longer referenced from anywhere, so that can be garbage collected. And again, let's remove that from the diagram straight away. Back in the another method, and the next thing that happened is we create a second instance of our container object. Now I'm going to slightly shortcut here and just draw on screen the new objects without showing the code for the container methods on screen once again. Note that it's a new instance of container. This is not pointing to the existing instance. The next line of code sets initial holder equal to initial2. So this is changing the reference for the initial holder variable to point to the same place that the reference to initial2 is pointing to. Note that the original container object is still being referenced from the out-of-scope container variable, so this won't be garbage collected at this point, it does still exist. Well, we now have two lines of code that are going to do the printing, so this will be the first bit of output. The first line is printing out initial holder.getInitial. We can follow along the lines, here's initial holder, here's the initial, so we expect the first value output to be the letter A. The next line prints out new initial. Well, again, we can follow the lines, here's new initial, that should be the letter Z. So our output should be A and then a Z, both in uppercase. Now we return to the main method. So at this point, initial2, initial holder, and new initial will be all popped off the stack, and our container and last variables will come back into scope. And our final line of code is going to print out the value of container.getInitial, and once again we can trace along his container, and the initial will be a string with an uppercase value of B. So after all of this effort, and it was quite a lot of effort, we can predict that the outcome is the letters all in capitals A, Z, B. Let's run the code now in Eclipse to check that was right. So here's our main class, we'll click on run. And indeed, in our output in the console, we've got the letters A, Z, B. Well, that's a relief. I hope you got that right. This was a pretty complicated example. If you did manage to trace it through and get the right answer yourself, then well done.